If you attend any serious cybersecurity conference in 2026, Black Hat, DEF CON, RSA, or any of the smaller regional gatherings where the people who actually do this work congregate, you will notice something that would have seemed impossible a decade ago. The laptops on the tables are not Windows laptops. Not most of them. Not anymore. What you see instead is a sea of Linux distributions, a scattering of Macs, and the occasional heavily modified Windows machine running stripped-down custom builds. When you ask why, the answers are consistent, detailed, and, for those of us who have been watching this trend develop, increasingly hard to dismiss. The professionals whose entire job is understanding how software fails, where attacks come from, and how to defend against them, are abandoning the operating system most consumers use. The reasons they give are not ideological, they are practical, and they apply to you whether or not you work in security yourself. Let me walk you through those reasons carefully, because this is one of those topics where the surface narrative is louder than the underlying truth. The first and most frequently cited reason is attack surface. Attack surface, in security language, means the total set of places where malicious code could potentially interact with a system. Every service, every driver, every exposed port, every pre-installed application, every automatic background process is part of the attack surface. The bigger the attack surface, the more opportunities exist for something to go wrong. Windows, particularly Windows 11 in its default configuration, has a very large attack surface by design. It runs dozens of background services. It ships with Edge, Teams, OneDrive, Cortana, widgets, Microsoft Store, and a catalog of pre-installed applications most users never launch. Each of those represents code that runs, sometimes with elevated privileges, and each of them is a potential door. A minimal Linux installation has a much smaller attack surface. You install the applications you need. You start the services you want. Nothing is pre-installed except the kernel and a handful of core utilities. If you never install a web server, you never run a web server. Windows, by contrast, runs services you may not even be aware of, including several that listen on network ports by default. Security researchers look at this architectural difference and reasonably prefer the smaller attack surface. It is easier to understand. It is easier to audit. It is easier to harden. The second reason is auditability. This is where the open source nature of Linux matters in a concrete, measurable way. When a security researcher wants to understand how a piece of Linux behaves, they can read the source code. They can verify that the system call does what the documentation says it does. They can compile their own version with modifications for testing. They can trust or verify the entire stack from the kernel up through the desktop environment. Windows is a black box. A well-documented black box, but a black box. Microsoft provides extensive documentation of the behaviors it wants you to know about. The behaviors it does not want you to know about, or the behaviors it has not documented, are invisible. Researchers have discovered undocumented Windows behaviors in the wild, often through the painful process of reverse engineering real-world attacks. That work is slow, expensive, and never complete. The third reason is update control. I have touched on this in earlier videos, but it is worth saying again in the security context. On Linux, you control when and how updates are applied. You can delay them, inspect them, roll them back. On Windows, updates are pushed on Microsoft's schedule. For a security professional, that loss of control is intolerable. If you are working on a sensitive project, a pending patch you have not yet verified is a liability, not an asset. A forced reboot in the middle of an investigation is a disaster. The control that Linux gives the user is, in the security community, considered a basic requirement. The convenience Windows provides for the average user is, for professionals, a bug. The fourth reason is tooling. This one is practical rather than philosophical. The tools that security professionals actually use for their work, penetration testing frameworks, forensic suites, reverse engineering platforms, network traffic analyzers, are overwhelmingly native to Linux. Tools like Metasploit, Burp Suite, Ghidra, Wireshark, Volatility, and dozens of others run best, and often run only, on Linux. Windows has ports of some of these, and Microsoft has worked hard with WSL, Windows Subsystem for Linux, to make more Linux tooling usable on Windows. But for people who use these tools every day, running them on their native platform removes friction and edge cases. Kali Linux, Parrot OS, and BlackArch are specialized security distributions built around this reality. They exist because the need exists. The fifth reason is threat realism. Security professionals spend their days thinking about what bad actors actually do. They know, with detail most users do not, how phishing attacks work, how privilege escalation works, how lateral movement through a network works, how persistence mechanisms hide themselves. When you understand the attacker's perspective in detail, you start to notice that the features of Windows that make it user-friendly, the shared clipboards, the automatic file previews, the integrations with cloud services, the cross-device synchronization, are also the features that make Windows exploitable. Each convenience is a data flow. Each data flow is a potential interception point. each integration is a potential privilege escalation path. Professionals trade convenience for predictability, because predictability is what lets them sleep at night. Let me give you a specific example that was discussed at Black Hat last year, and that has become something of a reference point for this conversation. The print spooler service in Windows has, for decades, been the source of some of the worst remote code execution vulnerabilities ever discovered. Print Nightmare, discovered in 2021, is the most famous, but it is not the only one. The reason Print Spooler has been so problematic is that it runs with high privileges, accepts network connections, and has a long history of design choices that assumed a friendly network environment. Researchers have pointed out that you can disable Print Spooler on Windows if you do not need to print, and this is Microsoft's recommended mitigation. But the service is on by default. It has been on by default for 25 years. A design decision made in the 1990s, when networks were assumed to be trusted, continues to run on hundreds of millions of machines in 2026, where networks are definitely not trusted. Disabling it requires administrative knowledge most users do not have. On Linux, the equivalent service, CUPS, is not installed by default on minimal distributions. On desktop distributions, it is installed but runs in a different security context. When CUPS vulnerabilities are discovered, and they are discovered occasionally, the impact is smaller, because the service is more isolated, and because users who do not print can uninstall it entirely without losing other functionality. This pattern repeats across dozens of Windows services. On Windows, the default is friendly and the hardening is optional. On Linux, the default is minimal and the features are optional. The implications for security professionals are obvious. The sixth reason is the vendor relationship. Security researchers have complicated relationships with Microsoft. Microsoft's bug bounty program is one of the best funded in the industry, and Microsoft has, over the last decade, substantially improved its response times to reported vulnerabilities. But the relationship is still fundamentally adversarial. Researchers disclose, Microsoft pushes back, sometimes on the classification of findings. Researchers publish, Microsoft sometimes patches. The process works mostly, but it is slow and politically managed. With open source software, the process is faster and more transparent. A vulnerability discovered in the Linux kernel or in a major Linux application is discussed publicly, patched publicly, and distributed publicly. The patch arrives on user machines typically within days. On Windows, the cycle from discovery to user delivery is measured in weeks or months. Now, the honest part. Linux is not magical. The security community is not unanimously enthusiastic about every aspect of Linux's model. Open source code can contain bugs that go unnoticed for years, as the Heartbleed vulnerability in 2014 demonstrated dramatically. Linux distributions vary in their security posture, and some older or smaller distributions are actively worse than Windows in specific scenarios. The human who operates the machine matters more than the operating system they run, and a careless Linux user will be compromised faster than a careful Windows user. None of the professionals I have discussed this with claim otherwise. What they do claim is that, given equal user skill, Linux provides a more predictable, more auditable, more controllable computing environment. That does not mean Linux is the right choice for every user. For a family member who needs to click on email and browse the web, the cognitive load of managing a Linux system is almost certainly worse than the cognitive load of managing a well-configured Windows system. For a professional who needs to work on sensitive material, manage their own security posture, and trust the stack they are building on, Linux is a better tool. What should you do with this information? First, consider your own threat model. Are you a casual user who reads email and watches videos? Then the security differences between Windows and Linux are probably less important. Then the usability differences, and Windows configured reasonably and kept up to date is fine. Are you a professional who handles client data, intellectual property, or personal information that would be embarrassing or legally fraught if compromised? Then the trade-offs shift. Are you a journalist, an activist, or someone working on something that might attract serious attention? Then Linux deserves very serious consideration. And beyond Linux, specialized distributions like Tails and Qubes OS, designed specifically for high-threat use cases, deserve to be on your list. Second, audit your Windows configuration if you're staying on Windows. Disable services you do not need. Uninstall applications you do not use. Turn on the privacy settings, the firewall rules, and the account protections that Windows ships with, but that are often underused. Microsoft's own security compliance toolkit publishes recommended hardening baselines. They are accessible. They are free. They work. Third, seriously consider whether your daily workflow actually needs Windows. Many people who assume they need Windows when they inventory their actual tool usage discover they mostly use a browser and a handful of cross-platform applications. The perceived dependence on Windows is often weaker than the actual dependence. The professionals who have switched tend to be people who did this inventory honestly and discovered the gap. The broader point is this: security professionals, The people whose careers depend on understanding how software fails are voting with their installations. That vote is meaningful because their professional lives depend on making the right choice. When a large and growing fraction of a profession moves in one direction, it is worth understanding why. You do not have to follow them. But you should understand the logic, because the same logic probably applies to your situation more than you think. I'm going to keep following this story because the gap between the security community's consensus and the consumer market's defaults is one of the more interesting tensions in modern computing. Those two communities are more or less deciding different things are acceptable, and eventually one side is going to have to change. My bet is that the consumer market, driven by regulation, breach fatigue, and the emergence of easier alternatives, will drift toward the security community's position over the next 5 to 10 years. Whether that bet is right, we will see. Subscribe if you want the follow-up, where we walk through specific hardening steps you can take on Windows if you want to narrow the gap without switching operating systems entirely. And in the comments, I want to hear from anyone in the security community, professional or amateur, what moved you off Windows, if you have moved, or why are you staying if you have not? The honest answers matter. The marketing answers do not.